principle of relativity was in fact first advocated by Galileo, and it says the laws of physics should have the same form in all inertial frame of reference. But have you ever thought, what does it really mean? Should the laws be exactly same? Or can they even vary? So, let's discuss. Welcome to another session of our discussion in physics. This video is a part of a series on the introduction to general theory of relativity. However, you can view this video independently as well. So in order to appreciate it, first we must understand what does one really mean by an inertial frame of reference. Inertial frame is a reference frame where an object remains at rest or moves with a constant velocity unless acted upon by an external force. In other words, inertial frame is a frame where Newton's first law of motion holds true. Further, if you find one inertial frame, any other frame which is moving with a constant velocity with respect to it is also an inertial frame. As you see here, if frame O is an inertial frame, then the frame O prime is also an inertial frame. Now we may ask the question, how are the coordinates of these two inertial frames related? This question leads us to the so-called Galilean transformation. Consider a particle P whose position with respect to an inertial observer O is given by the vector r. With respect to another inertial observer, say O prime, the position is given by r prime vector. If the observer O prime is moving with respect to the observer O with a constant velocity v, then at a time t, the position vector of the same particle can be related as you see here. Further, if we refer the time measured by the observer O prime as t prime, then the elapsed times of these two observers can be related as you see here. In summary, by Galilean transformation, one refers to these two relations. We now have two inertial observer O and O prime, and the principle of relativity says that these two observers should have the same laws of physics. Now one may ask, what do you mean by the laws of physics? Which law are you referring to? In the context of Galilean transformation, by laws of physics, one really means Newton's law of gravitation and Newton's laws of motion. We're going to check now whether these two laws have the same form in the O frame as well as in the O prime frame. The Newton's law of gravitation say that force between two masses m1 and m2 is proportional to the product of their masses and inversely proportional to the distance squared between them. So the question one may ask now, whether the same statement holds true also in the O prime frame. As you see here, the distance vector between these two masses remains same under Galilean transformation. Therefore, it implies that Newton's law of gravitation has the same form also in the O prime frame. Of gravitation as an example, we see here that the force due to m1 on m2 is indeed equal and opposite to the force due to m2 on m1. Now we may ask the question whether Newton's third law has the same form also in the O prime frame. As you clearly see here that it is indeed true, the Newton's third law has the same form also in the O prime frame. If you use the rules of Galilean transformation, we see that in both O as well as in O prime frames, mass times acceleration is equal to the force, as the velocity v vector is a constant here. If you have enjoyed today's video, then please feel free to follow the other videos that are available here.